Chapter 3.4 is solving multi-step inequalities. You might be wondering why we're skipping 3.2 and 3.3, but 3.2 and 3.3 are just kind of solving ideas that deal with the inequalities themselves, and I think that we covered most of what we needed in Chapter 2.4. If you want to go back to that video and watch it, Chapter 2.4 actually started showing you how inequalities work. But other than that, we just completed a chapter on solving equations, and we've been exposed to these topics. You've learned how to, or you should have learned how to solve one-step equations. You should have seen how to solve two-step equations. You should have seen how to do multi-step equations. That's the one where you distribute before solving, or you combine like terms before solving. And we also learned how to deal with it when variables are on both sides. If you have at least a firm grasp, not a perfect grasp, but at least a good grasp on those topics above, then this section should be under your control. The essential question for this lesson is, what changes from what I've already learned? What changes from what I've already learned about solving equations? I'm sorry, I read that the wrong way. The inequality symbol is not affected unless one of two things is happening. So the inequality symbol will stay the same. If you notice, whenever I had x plus 3 equals 6 and I subtracted 3, the equal sign just came down. Same thing if I have x plus 3 is less than 6 and I subtract 3, the inequality will stay the same. It doesn't change. Same thing if I had x plus 3 is greater than 6 and I subtract 3, the sign does not change. So again, it is not affected unless one of two things is happening. Once you learn to look for these two things, everything else is going to be fine. Again, notice equal stayed equal, less than stayed less than, greater than stayed greater than, but that's because what we are looking for, those two things, was not in this problem. So in most situations, you can ignore the symbol, or ignore what the symbol is doing, but you have to keep a lookout for the trick problems that exist, because if you don't, then you're going to get caught. Basic rules of the inequality symbol is that it will remain exactly the same unless, and you need to write these down, unless we are changing all signs, which we've done that before, or unless we're switching sides, because remember that we can't have the variable on the back side of the equation, it has to be in front. So again, if we are changing signs, that's one time when the symbol has to change, and when we are switching sides. Those two things you have to look out for constantly in this chapter. If you do not start looking for that constantly in this chapter, then you're going to cost yourself a lot of points, because things are not going to end well. Very quickly, I want to work through these examples that you've pretty much already seen if you've done your homework, so that we can get to the practice and you can get to actually asking questions. Here, y is on the right side, we need to move the 9, so of course we know we add 9 to both sides, we get a 20, we get this symbol, we get a y. The problem again is that in order to graph this, my variable must be in front, so we move our y over here and our 20 over there. Because I am switching sides, because my y was on the wrong side, guess what? This symbol has to turn around. And then when I go to graph that, which I said you're going to have to do on everything, so you might as well practice it, that is a closed circle with an arrow pointing to the left. And so we're looking at numbers like 20, 19, 18, 17, or 10. For example, 10 would be in that answer. 10 minus 9, notice, is smaller than 11, so that would work out. But other than that, that's what you have to look out for. So again, if you're switching sides, that's one time when the sign will switch, and if you're switching signs. But in questions like this, two-step equations, I was taught you to move the smaller x, so we're going to move the 6x. We are not switching signs, we are not switching sides, we are just moving the 6x, so that ends up being 3. Notice the sign will not change, or the sign won't change, I guess is how I should say it. Not notice it doesn't change, but the sign stays the same. It also stays the same whenever I move my 1, because that doesn't hurt anything. Again, the sign stays the same, 2x comes down. When I divide by 2, again, the sign is not doing anything because nothing major is going on. But now that x is on the wrong side, I must switch sides, which means that now I have to bring my x over here, put my 2 over there, and the sign will flip around. In this case, when I go to graph it, it is an open circle pointing to the right, and there you go. But again, the only time the sign is affected, notice it stayed the same on 1, 2, 3 steps and then switched on the 4th. Those two things that you need to look out for, you must look out for immediately and all the time. Alright, looking at this one, when I move this 4 by making it negative, because that's a positive 4, I bring down my negative x, sign does not change, I bring down my 4. But notice that x is negative and I cannot end with a negative x, so what I have to do is change the signs, which means that now I'm going to make x positive, 4 negative, and so the sign must switch. That sign switches also. So you must switch 3 things now. whenever you change your x from negative to positive. Hopefully you've been practicing that over the last couple weeks I've given you. But again, when you switch your x and your 4, you must now also switch that sign. Again, this would be an open circle with a negative 4 pointing to the left, whereas that would accidentally make you point to the right, which is going to cost you points. So you need to be careful. This one here has both things that we have to look out for. First off, we notice that x is on the wrong side. We also should notice that x is negative. So the first thing I would do, because this is what I taught you to do, or try to teach you to do, is switch all the signs. So I would make that negative 3, flip the sign over, x over 4. I would then solve by multiplying everything by 4 the way we were taught. And remember, if you don't show your work, you miss it, so make sure you practice that. Negative 12 comes down. Again, that doesn't affect the sign because I wasn't changing anything. I'm just moving numbers. Now that x is on the wrong side, we must bring it over, put our 12 over, and again, flip that sign over so that we have the right answer. It's going to be closed because it's less than or equal to, and it's going to be pointing to the right. And then because we do have a test pretty fast, I want to kind of introduce you to a different type of situation here where you actually have two symbols, which means before we had a left side and a right side, now we have a left, right, and middle. And the only thing that happens in this problem here is that whatever you do to one, you must do to all. Your goal is still to get the x by itself. You still follow the rules of math. The only difference is instead of doing it twice, we will now do it 3 times. Watch for example, and you will see 2x plus 1. If you have negative 15 less than 2x plus 1 less than or equal to 21, first thing we would always do is move the 1 by subtracting 1. But now we must subtract 1 here, here, and here. Negative 15 turns into negative 16. Be careful on that. Again, the sign does not change. 2x comes down. The sign does not change. Be careful to make sure that it has the line and that is the right one. And then that, of course, turns into 20. This is legal. Now we're going to move the 2. So what we're going to do is divide all sides, not just both sides, by 2. You end up with negative 8 less than x less than or equal to 10. And that is it. Now when you go to graph that, notice that x is in between these numbers, so there are actually two important numbers, negative 8 and 10. Notice that the attachment between negative 8 and x is open. Notice that the attachment between x and 10 is closed. And again, x is in between those two things. You won't really have to graph that, but again, that's what that graph looks like. Alright? So overall, you got to begin to accept the responsibility of learning the material through your own discipline. Again, I have been tough on you, or tough on some of you, because you were failing at a time you should not have been failing, which is at the beginning of the book, and the material only gets tougher. I was only tough on you because if you don't learn to study, if you don't learn to practice on your own, ask questions like you're supposed to, those things that I've been trying to encourage you to do are now going to become very, very important, because if you don't learn to practice new processes, then by the time the test comes up, you're going to be buried by everything and you're not going to pass the test, and you're going to have to take this class over. So please make sure that you start, again, being accountable, or making yourself accountable for what you're doing. Don't just sit in class and mess around. Don't allow things to pass you up for 2 or 3 days in a row. You have to now start making sure you are doing your job. So again, please be sure to work hard every day and you'll be fine. Otherwise, again, you're setting yourself up for a difficult time. The test for this chapter, again, is next week, because we have the end of the quarter coming up next week. And you also have all of your makeup work due Friday. Actually, I guess you could say due Thursday or Friday morning, because I won't be here after school Friday. But other than that, like I said, just make sure you make the best of this time, make the best of the material, because I think the material is easy enough to do, but you have to take it seriously enough on your own, because I'm not going to be here to force you to learn it. So I'd say go to your Math Excel, get as much stuff as you can done, and let's get it done. Good luck.